This is section 6.2, business applications number 1. What we're doing today is we're trying to start talking about the relationship between calculus and business. So a lot of times when economists are looking at profits and revenue and cost, they like to look at the marginals. And the marginals are just the rates of change of the profit, the revenue, the cost. And it's with respect to the number of units that we're producing or selling. So some basic terms that you need to know to be successful with this is that X is always going to be the number of units that we produce or sell. So if we're going to sell, I don't know, hoodies, if we're going to sell hoodies before school starts, X is going to be the number of them we sell. P is going to be the price. So let's say we're selling them for $20. R is going to be the total revenue. Well, if I wanted to know how much money we're going to bring in, let's say we make 100 of them, we produce 100 of them, and we're selling them for $20. So we're selling 100 of them at $20, so 20 times 100, that's going to be $2,000 from our revenue. C is the cost. So the cost of producing X units. So we might have to pay for them. Maybe we can purchase our 100 hoodies. Maybe somebody say, hey, I'll make those 100 hoodies for you for $200. Okay? So at this point, we just said that we've got 100 of them that we're going to sell. We're charging $20. The person tells us that they will make all of them for us for $200. So right now, our revenue, like we said, X times P, 2,000. Cost, our cost was $200. So then if we want to find the cost that it cost us per item, well, we would just have to do 200 divided by 100. What was our cost? It was 200 total for this big box of hoodies. There are 100 of them in there. So our cost is $2 per. So profit is our total profit from selling X units. So our profit is going to be our revenue, which was here, 2,000, minus our cost, which our total cost was 200. So 2,000 minus 200, $1,800 would be our profit. You never want to have a break even, but the break even is when your revenue is equal to your cost. All right. So here we've got marginal revenues. Well, the marginal revenue is the extra revenue we're going to make from selling one additional unit. The marginal cost is the extra cost of producing one additional unit. The marginal profit is the extra profit from selling one additional unit. And these are all just the derivative with respect to X. Now remember, we're going back to the derivative with respect to X. We've been doing with respect to time for a while with related rates, but now we're going back to the derivative with respect to X. Looking at the first example, it says the price or the demand function of a function is 8 plus 10 over the cube root of X. Find the revenue function. Well, if this is our price function, to find revenue, that's always X times P. So my revenue is going to be X times 8 plus 10 over, this would be X to the 1/3. So distributing that out, revenue is going to be 8X plus, if I have 10X over X to the 1/3, bases alike, subtract the exponents, that's 10X to the 2/3. That would be our revenue function. And the marginal revenue function, that's the derivative of the revenue with respect to X. So dr dx is going to equal this derivative, 8. 10 times 2/3 is 20/3. X, subtract 1. Or, that would be equivalent to dr dx. I can also call that just r prime for dr dx. But now it says find the approximate extra revenue from selling one additional item when 1,000 items are sold and when 2,000 items are sold. Well, all I have to do is find r prime of 1,000. Plug in 1,000. 8 plus 20 over 3 cube root of 1,000. So that's going to be 8 plus 20 over cube root of 1,000 is 10. Times 3 is 30. So that's going to be, this is revenue, so we're talking money. So r prime of 1,000 is going to be $8 and 67 cents. 2/3 of a dollar, 67 cents. We have to find R prime of 2,000. What happens if we go from selling 2,000 to 2001? How much extra money are we going to make? So that's x plus 20 over 3 cube root of 2,000. I'm going to get a calculator out for that. So 8 plus 20 divided by, use parentheses, 3, go under math to get cube root of 2,000. So when we type that in, and we get $8.53. So we're still going to have more revenue even at 2,000 items produced, or sold rather. The cost function to produce X t-shirts is C equals 320 plus 2.5 radical X by the marginal cost function. So marginal cost function, that's just our derivative of C with respect to X. I need to rewrite this as 320 plus 2.5x to the 1/2. So to find the derivative of 320, that's a constant. 2.5 times a half. Well, half of 2.5 is 1.25. X, subtract 1. So there's our marginal cost function. You don't ever have to rationalize the denominator. Find the approximate extra cost to produce one additional t-shirt when X equals 200 and 300. All right, so to do something like this, I just want to plug in my values, 1.25 divided by the square root of 200. I'll use newer calculators. Okay, so let me jot that down. This will be called C prime of 200 is 0.09. So it's only 9 cents more to go from 200 to 201. On the newer calculators, I can just highlight that to pull it up, but on yours, if you have an older one, second enter, and then just change your 200 to your 300 to be able to do it quickly, and we have 7 cents. So C prime of 300 is 7 cents. Now, when you think about things like this, like why would it cost less to go from 300 to 301 versus 200 to 201? Well, you got to think of like your costs. If you buy a bunch of material and you buy somewhere a building to create your t-shirts, your cost per item goes down the more you produce. Because you've already, covered that startup cost, so it's really not going to cost you that much more. A manufacturing company finds that its product has a demand function of P equals 231 minus 0.025x and a cost function of C equals 18 plus 15x. Find the profit function. Well, if you look back, our profit function was revenue minus cost. Or we can think of it as XP minus C. So I have to take my price function times X. So my profit function is going to be 231x minus 0.025x squared. That's just revenue, because revenue is my price times X, however much I'm charging times however many I'm going to sell, minus my cost. When I do minus my cost, I have to make sure that I distribute that negative. So our profit function then, I'm going to have 231x minus 0.025x squared minus 18 minus 15x, simplifying, negative 0.025x squared plus 216x minus 18. That's our profit function. By the marginal profit function, that's just the derivative. So that's dp dx, or you can call it P prime. That marginal, I just take the derivative. Negative this times 2. Well, that's going to be negative 0.05 x to the first. And that derivative is plus 216. That's our marginal profit function. Find the marginal marginal profit when 500 units are produced, when 3,000 units are produced, and when 6,000 units are produced. Well, since I have so many of those to check, this would be a good time just to put my profit function in here for y equals negative 0.05x plus 216. Just trace, profit. Now I want to test all those values. Even though I can't see it, I can still test it as long as I make my window large enough. I'm going to be checking values up to 6,000, so I'm going to have to at least make my x max 6,001. So second trace, calculate the value at 500 is 191. So P prime of 500 is $191. So that means if I go from 500 to 501, I'm going to make an extra $191. If I go from 3,000 to 3,001, I'm going to get $66 more. And then for 6,000 units, I get negative 84. So think about that. Why is that happening? Well, sometimes you just make so many items, you produce so many items that you saturate the market and nobody wants it anymore. You know, there's designer clothing or designer handbags, whatever. You know, if they make too many of them, people are like, gosh, everybody has that. I don't really want it anymore. So, or maybe it's just the fact that, you know, everybody who wants one has bought one. It could be that case as well. So at some point, the marginal is going to become negative when you produce too many. So the sweet spot on this is when that derivative is equal to 0. So that means that you've actually maximized your profit. That's when you continue making more money until eventually, by producing one more, you're not going to make any more money. So this point right here, whatever that point might be, I can actually find it very quickly. Just finding that point of intersection. Get kind of close to it. So 4,320, that's the magic number for this. If you produce that many, that's going to be, if we go past that, we're going to start actually losing money. Our marginals become negative. Okay? So hopefully that all makes sense to you about the marginal profit, marginal revenue.